Millions of people around the world go out on the streets and rooftops to look at the amazing cosmic phenomenon. Another planet right next to the moon, a big red one. At first, everyone's excited. Mars showing up out of nowhere is having a strange effect on humanity. Just as the moon can affect the psychological and physical state of some people, Mars's unexpected visit is causing people to behave pretty strangely. Every night, the sky is lit up by the white light of the moon and the red glow of Mars. Many people get a sort of instant insomnia. Some even stop drinking coffee because they no longer feel sleepy. Mars brings out energy and a little wildness in people, making them laugh more, and even drives a few poor people crazy. They begin to go out of their houses more often and enjoy the unusual night sky. A few days later, everybody can see what's happening. Mars is getting bigger. Scientists announced that the red planet is slowly moving towards Earth. A collision is inevitable. Earthlings only have a few years left. A few months ago, a huge asteroid crashed into the red planet with such force that Mars simply flew out of its own orbit and went rogue. The chance that Mars would fly close to Earth was always going to be pretty high. After about 3 seconds of being announced, the news went viral, and panic set in. The situation's getting worse and worse. The closer Mars gets, the more it affects people on a physical level. Hundreds of videos pop up showing collision simulations of Mars and Earth. And there's no happy ending. Want to see what happens? One famous blogger asked her followers. The Earth's almost completely covered with water, and Mars is all dust, sand, and rocks. Then she puts a huge watermelon in the middle of her room. From the far end, she launches a bowling ball at it. Strike! Mars looks almost the same size as the Moon now. It's about to come into the Moon's orbit, and it's affecting the Earth's magnetic field. Floods, hurricanes, tsunamis, powerful thunderstorms. They go from bad to worse. Animals go crazy. Birds no longer migrate south. The polar northern lights appear in the Caribbean. The economy isn't handling the news that well. People stop showing up to work. Why wouldn't they? They just want to have fun and be with loved ones. There are enough resources on the planet to last until the catastrophe, so no one's even trying to fix the Earth's problems. Clothing, food, cars, yachts, whatever, everything loses its value and becomes free. Every day, huge street parties pop up all over the world. People decide to live their last months in peace and harmony. The global catastrophe is uniting humanity like never before. To go out with a bang, Earthlings team up to organize a huge rock concert. The red giant destroying our beautiful blue planet. Yeah, rock and roll's the perfect soundtrack. There's just enough time to eat, dance, party, and listen to good music. Huge stages are built all over the planet. It's every musician's last concert. During all that preparation, hope suddenly appears. Scientists have calculated all the events that'll occur when Mars crashes into Earth, and they have a simple plan. Luckily, humans had already planned on moving to Mars, so they already have been building spaceships for years. There's no time to get to another planet before the collision, but the good news is that people can wait out the disaster just outside Earth's orbit. You get to sit in a space station, munch some popcorn, relax, and enjoy the show. When the dust settles, it might just be possible to return to Earth, or what's left of it. After learning about this plan, people start working on finishing the ships night and day. Everyone in the world pitches in. There are still 2 years left before the big day. The huge concert stages are converted into more space stations. Mars is now giving people more energy, and with epic teamwork, people manage to create thousands of stations in just a few months. That's what happens when 7 billion people work together. Farmers, physical therapists, chefs, engineers, athletes, accountants, all on the same team. Mars is now closer to us than the Moon. The red giant blocks out the sun, and our planet is plunged into darkness. There are only a few days left. People are working like ants in a massive colony, putting the finishing touches on several 100,000 space stations. It takes 4 whole days for everyone to get on board. Plus, there's the loading of supplies. Animals, fish, seeds, plants, vegetables, fruits, video games, fruit roll-ups. The red giant is scheduled to enter Earth's orbit in a couple of days. That's when it will really pick up speed. Mars is only a little more than half the size of Earth, but up in the sky, it looks infinitely huge. The ships start taking off. People take a last look around, memorizing every inch. In a few hours, it'll all change forever. The stations fly up far enough away to clear any orbits. Two worlds colliding together should still have a soundtrack, though. Rock stars on every ship organize an outer space music festival. To the awesome sound of rock, Mars enters Earth's atmosphere and burns a thin layer of its own surface. This releases an incredible amount of energy. It gets faster and faster and smashes into the Pacific Ocean. A huge blast wave sweeps across the entire planet. Everything is lit up by flames, and everyone on the ships has to put on sunglasses to avoid being blinded. Our blue planet is turning into a fiery one. The dust of Mars mixes with the water of Earth. The force of the impact goes through the Earth's crust into the liquid hot magma. Hundreds of pieces of Mars, some the size of entire countries, are somehow floating in the atmosphere. The collision generates so much energy that all oceans boil and evaporate. Seas and rivers of molten metal are now spreading all over Earth. Days, weeks, months pass. A belt made up of bits of Mars forms around the Earth. It's like a fiery version of Saturn. It'll take a long time before it's safe to land back down, but humanity can't stay alive on the ships all that time. Food, water, and oxygen will run out after a few years. But scientists already have a plan. The ships flip a switch and become huge cryochambers. The ships are equipped with energy panels, and the roasting hot Earth's giving off a lot of energy. Totally enough to keep the ships working while everyone on board takes a few thousand-year nap. As soon as the planet cools down, humans will wake up. Hundreds of thousands of years pass. One day, alarms go off simultaneously on all the ships. People wake up, slowly. Their bodies are exhausted, but after a few billion cups of coffee, everyone's ready to go. Down on Earth, new continents should have formed, and the atmosphere is most likely way different. The planet might have lost its original orbit, so it might be spinning at a different angle. The seasons as we know them, gone. All the water on Earth evaporated in the first few hours. But there were huge glaciers on Mars, which might have melted on impact. Mars may have shared its water with our planet. The clouds of dust and dirt should have settled by now, and the ground should be pretty good for growing stuff on. All that magma probably spewed up a bunch of useful minerals and chemicals. It's going to be difficult, but humanity somehow must adapt to the new Earth. People are ready for anything. All the Earthlings run to the nearest windows to see what their beloved planet looks like after all these centuries. Where is it? People are craning their necks, looking out at the empty spot where the Earth used to be. The impact of Mars was so strong that it pushed the Earth out of its orbit around the Sun. It's gone. Great. What are we gonna do now? Some bearded guy grabs a guitar and says, "Let's play!" This planet's called the jewel of the solar system. Made up mostly of gases, it could float on water should you find a reservoir 75,000 miles across and just as deep. But what makes the planet so recognizable is its beautiful rings, gray, tan, and beige. They consist of dust, rocks, and ice. Some bits are as tiny as grains of sand, others as large as skyscrapers. The planet I'm talking about is Saturn, and right now, Earth is hurtling toward it at breakneck speed. It all started on a regular day over half a year ago. All of a sudden, Earth changed the course it had been following for several billion years. But instead of rushing towards the Sun, it started to move away from the star. On second thoughts, it might be for the better. We've got more time to find a solution. Earth used to move around the Sun at a speed of 67,000 miles per hour. For some mysterious reason, when it left its orbit, the speed remained the same. It means we're going to cover 746 million miles, separating our planet from Saturn within a year and 3 months. At first, no one realized what had happened, but a couple of hours later it became obvious. Despite the panic that engulfed Earth's inhabitants, nothing seemed to be out of the ordinary. But all too soon, it started to get colder and colder. Astronomers' forecasts were pessimistic. People started to leave their homes at the poles, move closer to the equator. Most plant and animal species were having a hard time. Some of them went extinct, even though we were trying to save them in greenhouses and special conservation parks. The sky changed dramatically. In a week, we could see Mars clearly. It looked like a big reddish sphere hanging low over our heads. Jupiter became as bright as the moon. Once Earth was as far away from the Sun as Mars, days became twice dimmer than they used to be. At first, our planet's atmosphere was acting as a barrier between people and space. That's why we didn't feel the cold immediately. But 7 days later, everyone who dared to leave their home had to be cocooned in heavy winter clothing. By that time, the temperatures had already dropped down to minus 145 degrees Fahrenheit. It got even colder once our planet passed Mars and hurried through the asteroid belt. It's been one of the most dangerous regions on our way so far. Yes, people could admire awesome meteorite showers streaking the sky. But several space bodies managed to get through the Earth's atmosphere. They slammed into the ground, flattening mountains and leaving behind gigantic craters. They caused tsunamis and triggered earthquakes. Right now, most of the planet, including the oceans, has already turned into an icy desert. There's a lack of food and natural resources. We've built underground towns and tunnels connecting them. Our scientists work day and night to find a way out of this situation. If they don't, that's what's going to happen. The closer our planet will be to Saturn, the more the ringed planet will loom over the horizon and the larger it'll look. Soon, it'll already shine brighter than the full moon. The massive yellowish-brown orb will be visible even during the day, but it'll look especially impressive at night. Instead of sleeping, millions of people will spend hours watching Saturn grow larger and larger. One day, the distance between the two planets will become the same as the distance between Earth and Mars used to be. Saturn's disk will be about a quarter the size of the full moon. Its rings will be as large as 2/3 of our natural satellite. Soon after that, our planet's speed will start to increase under the influence of Saturn's gravitational pull. The ringed planet is 9 times wider than Earth, and its mass is almost 100 times greater. That's why, instead of moving at a speed of 29 miles per second, we'll be dashing through space at almost 40 miles per second. That's 2,400 times the average car speed. Saturn's gravity will influence the moon more than that of Earth. In no time, we'll lose our satellite. It'll get catapulted into outer space, likely to go into an elliptical orbit around the Sun. If Earth wasn't about to crash into Saturn in the nearest future, the moon could one day cross paths with our planet again. No good would come out of such an encounter. But what's happening on Saturn's side of things? Saturn is one of the largest planets in the solar system, second only to Jupiter. Even though the rings surrounding the planet are huge, they're rather thin, less than a mile thick. Still, the main rings are large enough to stretch from Earth to the moon. But how did the planet get these breathtaking accessories? Beyond the outer edge of the main rings, A, B, and C, there's something astronomers call the F ring. Several million years old, it's the weirdest one. This constantly shifting ring is made up of icy material and is incredibly complex. Its curves, twists, and clumps of brighter substance make it look as if it's braided. Saturn has more than 50 confirmed moons. 2 of them, Pandora and Prometheus, flank the F ring on either side. They weave outside and inside the ring, acting like shepherds. They herd ice particles into a 60-mile thick band. But why are they performing this elaborate dance? No one knows. What scientists do know is that when Saturn's rings were evolving, icy material clumped together and formed moonlets. Some of them grew and turned into the planet's largest moons. But 2 of them collided. That's how the mysterious ring F appeared. If the moonlets had only been made up of small icy particles, the space collision would have left a ring and nothing else. but they had dense rocky cores. Those remained intact and turned into Pandora and Prometheus. People don't have any evidence Saturn's ever collided with another space body. Our Earth might be the first. But before crashing into the planet itself, we'll have to get through its rings, including the ring F. And no, our planet won't just punch a hole in them. Saturn's rings are made of small particles. Earth's gravity will start to pull some of them out of their orbit once we're close enough. It'll result in a long plume that will reach our planet. And later, when we squeeze through, the cloud of icy particles will drag after Earth. It won't have enough power to rid Saturn of its rings completely, though. They'll continue to move around their home planet, but their orbits will change and become more elongated. There will be no more stunning bands. Over time, the rings could probably settle down again, but Earth won't give them such a chance. The collision with our planet won't leave Saturn unscathed. If there's still a possibility to sneak a peek at the sky, people will be able to see the rings disappear into nothingness, but not for long. Soon, the largest chunks of rock will start hitting the surface of our planet, leaving behind lifeless land dotted with craters. In the worst-case scenario, Earth might even collide with one of Saturn's numerous moons. But let's imagine we've passed through this region in one piece, and now our planet's very close to Saturn. The gas giant might seem airy, but there's no way Earth can fly through the huge sphere and leave from the other side. Gravity is what keeps all that gas together. The very gravity that make our planet speed up. The closer it is to the much bigger space body, the stronger the pull is. It'll cause the fault lines on Earth to rupture. It'll also set off powerful volcanic eruptions all over the world. And then, with enormous force, our planet will crash into Saturn. The planet's atmospheres will get compressed. This will cause a dramatic and fast temperature rise, and in no time, the air will be on fire. Scientists claim that Saturn's core is dense, made up of iron and nickel, and surrounded by a rocky layer. But we'll never make it there. Earth will burn in the bigger planet's atmosphere after being literally torn apart. Our beautiful, blue-green world will turn into billions of trillions of tons of vaporized rock. Pity. Maybe Earth will become yet another Saturn's ring, instead of the ones it's ruined. Sounds grim, I know. Yeah, we can't save Earth from Saturn, but that's only a bad dream. So, maybe we take that effort and save us from a real threat, climate change. Just saying.
It all started with a minor change on our planet. At first, people noticed the moon had become brighter and a little bigger. But nobody paid attention to this. The moon affected tides all over the world. The water flooded the beaches, but it wasn't a tragedy. A lot of fish came close to the shores. People found giant squid, anglerfish, and other creatures next to the coast, although they usually live in the dark depths. New, stranger things happen every day. Birds no longer fly to the south in winter. They gather in huge groups, flying around cities with no purpose. The moon used to help them navigate in nature, so they can't figure out which way to fly anymore. In the boundless waters of the world's oceans, ship captains notice that compasses are now unstable. The arrow is pointing in different directions since the Earth's magnetic poles have changed. People realize the moon has started to approach Earth for an unknown reason. The moon's gravity affects the gravity of our planet. This entails changes in the climate, the behavior of all living beings, and the magnetic field. Now, it rains in the driest places and gets hot in the coldest lands. It's knocking down ecosystems all over the planet. People living near forests hear wolves howling all the time. The moon drives these animals mad. The Earth's natural satellite is growing in size and lights up the night much brighter. Nothing critical has happened yet. People don't panic because they don't want to believe the end is coming. But then, one day, the moon reaches a critical point. You're walking down the street listening to music, and at that moment, someone pushes you. Okay, maybe that guy is late for work. You keep walking, and a girl coming by hits your shoulder. "I'm sorry," she says, and goes away. You've noticed the fear in her eyes. You look ahead and see people running towards you. You take off your headphones and hear screams and sirens. People leave their cars and run away. Hundreds of seagulls are flying in the sky. You hear a strange noise among all the sounds of chaos. It seems to be water. How is this possible? You're in the city center, a few miles from the shore. But there's no time to think. You notice a huge wave flooding the streets and heading straight to you. You run into a building and go up to the 10th floor. From here, you're watching the water filling the city. The strong stream blows all cars, one-story buildings, and trees off the road. You notice a shark and other fish in the water. People are hiding in houses and on the roofs. The whole city is quickly plunging into a catastrophe. The TV is working in the building where you're hiding. You learn that floods are occurring all over the world. Massive tsunamis cover coastal cities. In some places, waves reach the height of a 30-story building. Many towns have been washed off the face of the earth. The moon is too close to Earth, and massive floods are just the beginning. The moon flies around Earth and helps to keep our home on its axis. The moon provides climate stability and helps living organisms develop. But now, this balance is broken. The moon is approaching and changing our planet's gravity. Earth can tilt slightly to the side and provoke massive floods around the world. Imagine that you're holding a round glass of water. Tilt it a little. See how the liquid moves from one side to another? The same thing is happening now with the oceans. But the moon is not just approaching us. It's flying around the planet and getting closer with each circle. It causes natural disasters in different locations on Earth all the time. Now the ocean floods one side, and a few hours later, another. So you see all the water going back from the streets to the shore. The oceans may return to the city again by the end of the day. Wait a minute. It seems the end of the day has already come. You notice that the sky has become dark. It's weird, because it's only 3 p.m. The moon changes Earth's rotation speed and makes the day go faster. The moon covers almost the entire sky and brightly illuminates our planet. You see huge lunar craters. It's so close that you can still see it even when the sun shines. In some places, the passing moon obscures the sun. The water is leaving the streets and everyone goes outside. At this moment, an earthquake begins. The road is cracking and the houses are collapsing. There are landslides on the street. Tectonic plates are shifting all over the planet. Imagine two magnetic balls that are approaching each other. So, one ball is the moon, and the second one is Earth's core. What do you think will happen to what's above the core? That's hundreds of thousands of miles of the Earth's crust. And now, it's all moving. Destructive cracks are emerging all over the world. The planet's highest mountains break down and turn into a pile of stones. The seabed cracks and releases magma from the underground depths. Volcanoes wake up and erupt magma. Clouds of volcanic ash cover the sky from the sun and the glowing moon. But the scariest thing is still ahead. A collision is inevitable. The moon flies around the planet like a ball in a round glass with a hole in the center. This force drives clouds all over the planet. Now there's a thunderstorm, but in 5 minutes, it will be snowing. Then the night comes, and it starts raining. Water droplets consist of mud and volcanic ash. It's difficult for people to breathe without gas masks. Atmospheric pressure is constantly changing. Some people experience severe migraines, and some have sore joints. But there's no time to think about your health. Humanity needs to figure out how to save itself from the collision. A new gravitational order will come when the moon crashes into Earth. Continents will change their shape. They will combine into one giant piece of land or split into 100 smaller ones. The energy of the collision can burn all the oxygen in the atmosphere and make the planet unsuitable for life. Hiding underground also makes no sense because of deep earthquakes. People decide to spend their last hours with loved ones and their families. The moon is getting closer. It's now at the same distance as the International Space Station. The moon covers the sky. Many cities are in the shadows because of the waves. Tsunamis, several miles in height, crash down on the ground. Millions of tons of magma collide with the ocean. Billions of gallons of water just evaporate. Moisture rises into the air, mixes with ash, and floods the land in the form of giant cumulus clouds. You've accepted the complete destruction of the planet, but something strange happens to the moon at this moment. You notice giant cracks appear on it. The moon slowly begins to divide into two parts. Both halves crumble into hundreds of large pieces. It's just falling apart. The Earth doesn't have a natural satellite anymore. It's just a pile of giant space rocks. But why is this happening? There's a space around our planet called the Roche limit. In this place, the gravity of Earth is stronger than that of the moon. This means that the forces holding the moon together are weaker than those that tear it apart. People are cheering. The Roche limit has saved the planet. The moon won't hit us. It breaks up into millions of fragments and forms a circle around our globe. Now, Earth looks like Saturn. A belt of moonstones surrounds us. Huge chunks destroy everything in their path, all the space debris. The satellites are no longer working. Humanity loses its means of communication and navigation. People will have to use paper maps again. The moon held our planet's orbit at a certain angle before these events. Now the axis is tilted differently. One hemisphere becomes closer to the sun, and the other plunges into shadow. The North Pole and the Arctic may turn into hot deserts, and the equator of the planet may be covered with ice. Winter and summer can last for years. The moon's remnants fly around Earth, but some of them fall on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the massive destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world.
As you know, all the planets in our solar system orbit the sun and bring a sense of order to the place. But guess what? There are two planets that could collide with each other and cause a cosmic catastrophe. Here's Neptune, the most faraway planet in our solar system. It's 17 times heavier and 4 times bigger than the Earth. It's 30 astronomical units from the Sun. 1 AU is the distance between the Sun and the Earth, so it's 30 times farther away from our star than we are. And Neptune makes a complete circle around the Sun in 164 years in an almost perfectly round orbit. Neptune is cold, calm, and stable. But there's one planet that can ruin this balance: Pluto. It's a dwarf planet covered in rocks and ice. It's 6 times lighter and 3 times smaller than the Moon. We're interested in its orbit. If you look at a map of the solar system from above, you can see that it's not round but elliptical, so it's a slightly flattened circle. At its furthest point, Pluto is 49 Earth-Sun distances away from the Sun. When it moves, it comes closer to the star. At its closest point, Pluto is about 29.5 AU from the Sun. That's closer than Neptune. So, hypothetically, they could collide. Let's look at this collision from the front row. A little closer, please. Good. Neptune and Pluto are slowly approaching each other. They are both very cold worlds, but they begin to interact with each other gravitationally. Just like two magnets, it warms them up from the inside. Neptune is a gas giant. There's no solid surface there, so there's not much change in it yet. But Pluto has a rocky surface. Because of Neptune's gravitational influence, it's starting to crack. Pluto experiences continuous earthquakes. This causes it to heat up even more. When Pluto almost touches the gas giant, it begins to crumble from the inside out. Plus, Neptune has a very dense atmosphere, so the dwarf planet begins to ignite from friction with the gases in the upper atmosphere. Pluto is now very hot on one side and very cold on the other. This causes severe deformation, and it begins to crumble. Half of the dwarf planet's fragments remain in Neptune's orbit. They will collide with each other until they turn into dust and become new rings of the big planet. Other fragments will burn up in Neptune's atmosphere, and the biggest rocks that remain of Pluto will fall through Neptune until they're completely burned into dust. Neptune literally ate Pluto and continued its orbit without any change, all because the gas giant is 20 times larger and much heavier than the dwarf planet. So this collision would do no harm to Pluto. But it couldn't have happened in the first place, because their orbits don't actually cross. Let's look at the map of the solar system again, not from above, but from the side. All 9 planets here are on a horizontal line from the Sun. The distance between them is great, and their orbits don't cross. Here's Pluto's orbit. You can see that it's tilted relative to the horizontal line of all the other planets. It starts at the top, then dives under the orbits of the planets and comes back, so Pluto can never collide with Neptune. Still, planetary collisions have occurred in our solar system before, and thanks to these collisions, life appeared on Earth. Let's go back in time to almost 4.5 billion years ago. This ball of hot lava is Earth. It just formed from a cloud of dust and began to cool. But then, a wandering planet the size of Mars appeared on the horizon. It's called Theia. It was inevitably approaching our planet. The collision with Theia happened at a perfect angle. If Theia had hit us head-on, both planets would have been smashed to pieces. But it hit us almost at a tangent. Theia knocked some of the matter out of the young Earth and crumbled into rubble itself. It could no longer continue its journey because the Earth caught it in a gravitational trap. A large fragment of this planet remained in our orbit. Smaller fragments crashed into each other, falling to Earth or joining the remains of Theia. The dust settled, and we can see the familiar picture, the Earth and the Moon. This is the main theory of how it came to be next to us. Scientists say that it was this collision that caused life to appear on Earth. Theia brought a lot of ice on it, which turned into water on our planet. The new moon stabilized Earth's rotation, and conditions on the planet became perfect for the emergence of life. Another collision could create a blast wave that would spread out thousands of light years. Stellar collision. This usually occurs in binary systems with a white dwarf and a regular star like our Sun. A white dwarf is the remains of a star that has gone out. As the stars get together, they start to move around each other in a spiral-like dance. The white dwarf pulls down the upper layers of the larger star. This hot plasma and stardust form a luminous disk. The two stars get closer and closer. When they finally merge, this causes a chain reaction in the core of the hot star. The massive matter presses on the star's core too hard. This causes the innards of the combined star to heat up even more, and it expands, creating a supernova. This is one of the brightest events in the universe. The light from the explosion can be seen hundreds of light years away. Another spectacular view is the collision of a star with a black hole. Black holes are the heaviest objects in the universe, and their gravity is incredibly strong. So, when a star and a black hole get close, the black hole starts eating the lighter matter of the star. The hot plasma, like spaghetti, heads toward the heart of the black nothingness. For an observer, this plasma seems to settle on the very edge of the black hole. It's called the event horizon. The thing is that time is much slower near such a heavy object. So we think the matter stays on the event horizon, but in fact, it's long gone into the heart of the black hole. As they get even closer, the black hole starts to literally tear the star apart and swallows it whole. At this point, the black hole spits out about half of the star's mass in the form of a beam of energy right out of its black heart. The other half of the star's mass becomes the black beast's food. We know of many black holes in our universe. The heaviest of them usually lies in the centers of galaxies. They can be millions of times heavier than the Sun. But what would happen if two black holes collided with each other? Our scientists had the opportunity to observe such an event. Two black holes weighing 66 and 85 solar masses gradually approached each other. They danced together, bending the light passing by them. But then they merged into one enormous black hole, weighing 142 solar masses. That same second, the new black hole released gravitational waves into space with an energy of 9 solar masses. Scientists were able to catch these waves and observe the merging of the two black holes from the front seat. But this event actually happened about 17 billion years ago. We're only now seeing it because the particles of light and gravitational waves took so long to travel the distance of 17 billion light years to Earth. Now consider a galactic scale collision. Literally, it's a collision of the Milky Way and the Andromeda galaxy. This event will happen in 4.5 billion years, so stay tuned. The Milky Way has almost 100 billion stars. Andromeda has about 1 trillion. As the galaxies approach one another, they'll make several circles around each other. At that time, some stars may be ejected from the galaxies like from a slingshot. Then Milky Way and Andromeda will begin to merge. One scenario here is that our solar system will collide with another star system from Andromeda. In this case, there could be a stellar collision and a supernova afterwards. Our world would be destroyed. Another option is that the Sun would be ejected into dark space. In this case, we may not even notice the difference. All we'll see on Earth is a gradually disappearing starry sky, as our solar system will travel through dark space away from the home galaxy. But the most likely scenario is when the galaxies merge, it'll be completely painless for us. In fact, the space is very wide, and there's room for all the stars from both galaxies. The only difference is that we'll see a lot of new stars in the night sky, along with flying saucers from Andromeda. Nah, not really. But it's not the collision of galaxies that we should be worried about, it's our Sun. In 4.5 billion years, it'll become a red giant. It'll expand, swallowing up the nearest planets. Earth will probably be the first planet near the Sun. It'll be so hot that all life will simply disappear, and no one will be able to watch the galactic collision.
You're on a plane heading to an important astronomy convention when you see a large figure outside your window that eclipses the whole sun. You spit out all of your coffee, and everyone in the plane stares outside in shock. You then notice that it has rings like Saturn. You were supposed to fly to Japan, but you're forced to land in California. As soon as you land, you look up in the sky and see some more giant planet-like structures floating around in the sky. Everyone is taking pictures and trying to figure out what's going on. Suddenly, you notice a huge ball of fire crashing down near the airport. Everyone scrambles for safety, and luckily, it ends up in the middle of the runway with no one around. The bad news is, there's no more runway for planes to land. Everyone huddles together for safety, and more large objects appear in the sky. All communications have ceased or broken down, since these large objects have ruined all the satellites. Some scientists nearby mention that these objects are the planets of the solar system going within the same proximity as our moon. Mercury and Venus look like moons, but Saturn is occupying a lot of sky real estate. You tell those scientists that you're an astronomer. They invite you to join them on a trip to Antarctica, to the observatory station in the South Pole. They need every mind to help solve this mystery. You get on a ship with the coordinates set to Antarctica. The waves are extremely rough for typical daylight and non-stormy weather. You finally make it to the shore of the continent after a few days and have to get in a snowmobile all the way to Amundsen Scott's South Pole Station. Over here, you and a group of scientists will figure out what's going on. You weren't prepared for the freezing temperatures, even though it's July. You arrive at the station and see all your fellow scientists running around with paperwork and blurting out stuff about planets orbiting our atmosphere. You arrive at the conference room where the lead scientist explains what's going on. One by one, the planets are coming closer to us until they're aligned with the moon, but they still don't know why and how. Venus arrived first, and now Saturn is getting closer. The moon is around 240,000 miles away from Earth, and it affects the tides of the oceans and seas with its gravitational pull. Since water is less dense than land, we can see the tides change. So high tides occur when the Earth is pulled towards the moon. And since the other planets are coming closer to Earth, the gravitational pull is erratically changing. In a couple of hours, Saturn will be in the same distance as our moon. You head to the large telescope and observe the planets. Any plane or helicopter won't fly properly and won't have the proper radar technology to help it. You keep observing and notice Mars getting closer to Earth. You get news that tidal waves are rising very often now, and some island nations are even being washed away. Good thing they got evacuated beforehand. With Mars closing in, you notice Neptune also getting closer. You can feel the gravity on Earth fluctuate with every step you take. You report your findings to the lead scientist, and the only way for survival is to quickly build bunkers far away from oceans and seas that can host many people before the other planets close in. A team of engineers arrive and start building. Wave after wave of survivors come and settle into the bunkers, practically built overnight. With every hour, more planets are getting closer. Mars and Neptune have already settled in, with Mercury, Venus, and Saturn. Pluto and Uranus are now visible to the unaided eye and are making their way towards Earth. The gravitational pull is getting completely out of hand. The snow in the Antarctic desert remains floating for several seconds whenever someone walks on it. You can jump a lot higher. It's now nighttime, but the sky isn't dark as usual. The planets are reflecting a lot more sunlight than our moon. It's barely visible now. With more observations, you notice comets and meteorites flying very close to our atmosphere. Some are even crashing down on Mars and Neptune. Everyone can see it from Earth. Other space debris also finds its way into Earth's atmosphere. But you notice something strange. The planets are now orbiting Saturn. You check your calculations and find out that the planet's positions are now aligned with Saturn's orbit. That's because it has the biggest mass among all the planets. Saturn's rings are made up of ice particles, some as large as a bus and others as tiny as pebbles, but they're all crashing and interfering with the other planets. No one can feel the orbit shift at first, but later you can start to feel it. With this happening, earthquakes and volcanoes are bound to happen. This is why everyone, including yourself, is packing up and ready to flee. Antarctica has dozens of volcanoes hidden beneath the frozen ice. Some are underground, while some are right on top. Saturn's gravitational pull is much stronger than Earth's gravitational pull on the moon. This will cause the inner core to react a lot more and kickstart those earthquakes and volcano eruptions. Everyone packs up super quick and heads to the choppers to fly to South Africa. These choppers were designed to have a direct course without the need for radars to guide them. You arrive in South Africa, which is mainly covered in water. The chopper takes you closer to the center, and then you travel to the Sahara Desert. The plain surface with nothing around it will be the best option for safety. But you look up in the sky and see another planet closing in. It's Jupiter, the biggest planet in our solar system. If Earth were the size of a grape, then Jupiter would be the size of a basketball. It's approaching quickly. Many of the other planets automatically make way for it, including Saturn. You're on the road heading to the Sahara, even though it'll take days to reach by car. The sky is dark during the day, since most planets are blocking the sun. You finally make it to the Sahara Desert with other scientists, and to your surprise, a whole city was erected in just a month when the planets started showing up. You settle in your dorm, but still have a lot of work to do. A couple of days later, Jupiter breaches the atmosphere and completely eclipses us. But Earth is now rotating around it, and it's much quicker than orbiting the Sun, since Jupiter is smaller. But since Saturn is also big, Earth keeps getting tossed from orbit to orbit, like two people playing a ball game with each other. So with that happening, people on Earth are experiencing different gravitational pulls from time to time. The tidal waves keep getting stronger, and volcanoes are erupting everywhere. Since the Earth's core is getting hotter, the temperature on Earth is also changing. And with a lack of sunlight most of the time, much of the plant life is having a hard time trying to keep up. Crops are harder to plant with natural sunlight, so people are turning to artificial lighting and greenhouses. Air and space travel are impossible. The International Space Station is completely ruined, along with the satellites orbiting space. That's why cell phones and the internet can't work. Gravity is even more dysfunctional than ever. 6 months later, humanity has found some way of coping with the new normal, but things are constantly being updated. The number of hours in a day has changed, as well as days that compose a week. This used to be measured with the moon phases. A month used to be the moon achieving all phases from none to full moon, and so on. But Earth's moon has disappeared with the cluttered, disorganized planets.
There's this mysterious thing in space, an unusual spot that scientists haven't been able to explain for more than 15 years. There are different theories, and one of them says that maybe this is an imprint from a collision with a parallel universe. Is this true? Well, let's see. Take a look at this map. This is the map of our universe. Well, not really. This is actually the map of cosmic microwave background radiation, or simply CMB. Many billions of years ago, there was a Big Bang. It was so powerful that it created our entire universe. And, of course, such an event couldn't occur without leaving some consequences. And these consequences are literally everywhere. The Big Bang left electromagnetic radiation, which we know as CMB. We don't notice it in our daily lives, but it's literally here, under our noses. And if you had some kind of superhuman vision, you would see how everything around you shines with this dim light. This radiation is very important. If we hadn't discovered the CMB, we would never have found out about the Big Bang. Previously, scientists believed that the universe had always existed. There was no beginning and there was no end. It sounded pretty ridiculous to us now, but less than a century ago, people were absolutely sure of it. Stephen Hawking was one of the first scientists to guess that the universe did, in fact, have a beginning. The guy was so cool that he realized this as a student while working on his doctoral dissertation. But unfortunately, he had no proof. If there was such a strong bang billions of years ago, then where are the traces? Where's the proof? Laughed people who believed in the eternal static universe theory. But don't worry, they had the proof rubbed in their faces real soon. In 1965, astronomers Arno Pienzas and Robert Wilson discovered CMB, and that was the first grandiose proof of the Big Bang. It turned out that radiation was everywhere. We just didn't notice it. In fact, at first, Pienzas and Wilson themselves mistook it for the noise of a big city, or pigeons, or something else. For their discovery, which turned the world of science upside down, they received the Nobel Prize. Alright, so people learned that they were surrounded by electromagnetic radiation. Then they started collecting more data about it. They accumulated more and more info over the years until they made this very map. This is a map of CMB temperatures. But while creating it, scientists discovered something unusual. Let's take a look at this map. It looks like a large and diverse pattern of cold and warm places. But in reality, our universe is quite uniform. All temperatures on this map are close to negative 455 degrees Fahrenheit with very little difference. All temperature fluctuations between these places are small, and each tiny speck actually spreads over millions of light years. So everything in our world is pretty calm and stable, except for one point. This cold spot right here. Astronomers first discovered it in 2004. First, it looked like nothing unusual. It's just a region where the temperature is below average for a couple of microkelvins. But remember, we're not talking about a small area. This is a giant cold region. It's literally billions of light years in size. Wait, the scientists thought, this can't be true. The universe should be consistent everywhere. According to our standard model, this cold spot simply shouldn't exist. But it does exist though. This isn't just some mathematical error, it's right there. So what is this cold spot, and how did it appear? Astronomers have been trying to find the answers to these questions for years. Even now, we have only a few theories. So let's discuss them all. Theory 1. Cosmic texture. This idea was brought up at the end of 2007. Then scientists suggested that this cold spot could be the hills of space. In other words, it may be a bumpy region of the universe, just part of its texture. But that's a silly explanation, so this theory was quickly discarded. Theory 2. The supervoid. This hypothesis was considered the most plausible for a while. It stated that the cold spot was actually the so-called supervoid. It's a terrifying, dark place of our universe with almost no galaxies. And because it's an empty region with almost no stuff in there, it seems cold to us. However, this theory was refuted in May 2017. After carefully examining the cold spot, scientists found out that there were no signs of a supervoid there. Moreover, voids and supervoids, which actually exist by the way, are still very small in size. The cold spot is literally thousands of times bigger than them, so there must be some other explanation. And there is one, perhaps the most bizarre of them all. Theory 3. A parallel universe. This controversial idea was put forward by cosmologist and theoretical physicist Laura Mersini-Houghton. She suggested that the cold spot could be an imprint from the collision of our universe with a parallel one. Standard cosmology cannot explain such a giant cosmic hole, says Mersini-Houghton. This is the unmistakable imprint of another universe beyond the edge of our own. Her assumption is based on the theory of the multiverse. This theory says that there's actually an infinite number of universes like ours in the world. They constantly collide with each other, giving each other a push which creates a new Big Bang. So maybe the cold spot is a bruise from such a collision. For quantum mechanics, such crazy theories are pretty common, but for standard physics and our simple understanding of the world, this is earth-shattering. Of course, we need strong evidence. And Mersini-Houghton's team has begun to work on it. Professor Tom Shanks from the Center for Extragalactic Astronomy at Durham University also participates in this research. The craziest sounding of the exotic models for the explanation of the cold spot, the multiverse is actually the most standard in terms of our current model of the universe, he wrote in one of his works. So, what evidence do we need? Well, our cold spot is located in the southern hemisphere. According to Shanks, if there really was a collision between two universes, we should find another cold spot, and it should be in the opposite northern hemisphere. If astronomers actually found it, this theory would be confirmed, and it'd become the first proof of the existence of a parallel universe. But it's not that easy. To find a second spot, we need the latest, highly sensitive telescopes. We also need to find out some info about the nature of dark energy, how it affects space, and, in other words, there's still a lot of work to do. Not so long ago, scientists actually believed they had discovered the second spot. Researchers from New Mexico thought they had found it in the northern hemisphere. But unfortunately, this is likely to be a mistake. The map these researchers used had a high measure of randomness, so it's possible that their discovery is just an accident caused by other voids. So, basically, we haven't found another cold spot so far, despite careful analysis. But again, even the best modern equipment is not perfect, and it doesn't mean that there's no second spot. It just means that we haven't found it yet. But if one day we did find it, it could change the world of science forever. We'd confirm not only the theory of parallel universes, but also the famous string theory. It could explain everything that occurs in our world. But if this happens, we'll get even more questions than we already have. How did these two universes collide? How does it all work? So far, it's all just guesswork. We can't claim that the cold spot is a print from the collision of parallel universes. But we can't refute this either. Actually, we may never know the truth at all. But it's still interesting to strive for it.
This explosion is the brightest and most powerful in the history of our entire universe. And it was the start of absolutely everything. A Big Bang that happened 13.8 billion years ago. Elementary particles began to spread out in different directions and cool down into matter. This is the building material for the future universe. All the galaxies, black holes, stars, planets, asteroids, and even you and me. Yes, we're all created from the same set of particles that appeared at the Big Bang. A quick jump to 4.6 billion years ago. This is the nebula that's about to become our solar system. It's just a cloud of cosmic dust, rocks, and blocks of ice. Shock waves from supernovas from different directions around this place begin to push matter into a common center, just like sea waves. At one moment, all this matter begins to shrink around a center of gravity into one giant boulder. It attracts more and more other debris to itself. It presses on its own center so hard that nuclear reactions start there. A little more pressure and let there be light. And that's how our sun was born. 4.59 million years ago. This is when the first gas giant planets, Jupiter, Saturn, Uranus, and Neptune, are formed. They're composed entirely of gas and have no solid surface. Some say there was a fifth gas giant, but it was ejected outside the solar system. For another 100 million years, there's a solar nebula, a bright young star in the center, and a disc-shaped pile of gas and dust around it. These are remnants of matter from the original nebula. It's more like a boiling soup. The ingredients swirl around the sun, stirring and colliding with each other. They form the rest of the planets and moons of our solar system. When the dust settles, we can see Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, Saturn, Uranus, and Neptune. 4.5 billion years ago, while Earth is still a red-hot lump of rock and lava, Theia appears on the horizon. It's a protoplanet the size of Mars. It's formed close to Earth and is now flying toward it. Theia shatters into pieces and rips out a large chunk of our planet. A lot of debris is left in Earth's orbit and begins to come together. This is how the Moon was born. 4.1 to 3.8 billion years ago. This is the late heavy bombardment period. The remnants of debris that didn't become planets continue to travel through the solar system. They hit the gravitational fields of the freshly born planets and fall on them. Because of this event, we can see so many craters on Mercury and the Moon. Scientists have found the remnants of the oldest microorganisms in the world. They're about 3.8 billion years old. So, they were born around the time when the chaos of ever-falling meteorites ended. The process of evolution began. 3 billion years ago, strong solar winds and frequent meteorite impacts on Mars deprived it of its atmosphere. The atmosphere protected Mars from solar radiation, and now life can't be born there, although some scientists say that Mars was once inhabited. 2.5 billion years ago, an oxygen disaster is happening on Earth. Some organisms evolved to feed on the sun's energy and produce oxygen. Our atmosphere began to fill with it, and this washed away almost all pre-existing life forms. But it did pave the way for new ones. 100 million years ago, one of Saturn's moons was destroyed, either by a collision with a large asteroid or by the planet itself. The moon's debris began rapidly orbiting the planet and colliding with each other and turning into small rocks and dust. Most of this debris consisted of ice, and they remain to circle Saturn to this day. You can see it as rings near the planet. 66 million years ago, Earth suffers the impact of an asteroid the size of Manhattan. The blast waves from the impact can be seen from space. The ash cloud then completely covered the Earth and blocked the sun's rays. As a result of this event, most living organisms, including dinosaurs, ceased to exist. 70,000 years ago, let's look at the edge of the solar system. There's an area of asteroids and blocks of ice, the Oort cloud. And there's a rogue double star system approaching it. It pulls the asteroids out of the Oort cloud and throws them in our direction like a slingshot. Fortunately, the star passed by the solar system, but promised to return. 356 years ago. This is the date of the first discovery of the Great Red Spot on Jupiter. It's the source of strong winds on the planet, with speeds like the fastest supercars. If you compare this spot to the planet Earth, the spot is 30% bigger. Present time. The solar system looks exactly the same now as it did a few billion years ago, but humanity has added some new objects. You can see many artificial satellites and a vast international space station. Even on Mars, there are several rovers we sent there. Now let's look to the future. In the next few decades, Earth will constantly send spaceships to Mars. Every 2 years, when the distance between the planets is shortest, you may see an entire fleet of ships speeding toward the red planet. 100,000 years from now, the rogue star returns to the solar system. It disturbs the Oort cloud again and flies away. In 9 million years, it'll approach a record close distance of 52,000 Earth-Sun distances. 10 million years from now, Mars's moon, Phobos, has been steadily approaching the planet by 6 feet every 100 years. Gravitational interaction will first tear it apart. Some of the debris will fall on the red planet. others will remain in its orbit in the shape of rings, just like Saturn's. The future of the solar system depends entirely on the Sun. Every 1.1 billion years, its luminosity increases by 10%. This is because, over time, it'll burn more and more hydrogen fuel and get hotter. 1 billion years from now, Earth's temperature will become so high that liquid water will no longer exist. The oceans will evaporate, creating a greenhouse effect that will heat up the Earth even more. The existence of life here will become impossible. At this point, we see an entire fleet of ships flying toward Mars. These were the last inhabitants of Earth. As a result of the Sun's increasing brightness and temperature, its habitable zone, that sweet spot for life in the solar system, has moved farther away from the star. Mars is now much warmer. The ice beneath its soil became liquid and evaporated, creating a greenhouse effect. Now the conditions on Mars are perfect for humans. 3.5 billion years from now, Earth now looks like modern-day Venus. It's filled with lifeless landscapes, with volcanoes and dry riverbeds. 7.7 billion years from now, the Sun's hot core triggers nuclear reactions in the outer shell. As a result, the Sun begins to expand and becomes a red giant. The star will increase 256 times in size. It'll literally swallow the nearby planets, Mercury and Venus. While the Sun is insanely burning fuel, it's losing weight, and its gravity is weakening. This means that it no longer holds all the planets together as much, and their orbits expand slightly. So there's a chance that Earth will remain intact and will now be the first planet near the Sun. Mars has gotten too hot for humans too, and we're making another distant migration, this time to Saturn's satellite, Titan. This is the only place in our solar system where water in liquid form has been proven to exist besides Earth. Conditions here should now be suitable to welcome humanity home. When the Sun uses up a little more than half its fuel, it'll begin to shrink to a size 11 times larger than today. But in another 100 million years, it'll become a red giant again for the last time. After that, in another 30 million years, the star will begin to eject strong solar winds and stellar matter. There will now be a beautiful planetary nebula, which consists of the former outer shell of the Sun. The star will lose most of its weight, which means it'll no longer be able to hold the orbits of the planets. Chaos begins in the solar system. Some planets leave the borders of our world. Others collide with each other. But some of them will be able to stay here, but in a more distant orbit. And in 75,000 years, only a white dwarf the size of the planet Earth will remain in the center of the solar system. The Sun will gradually cool until it fades away completely. If there are still planets left, they will be cold and dark, incapable of supporting any form of life. From its birth to the end, the entire history of the Sun will take about 12.4 billion years.
Uh-oh. Something is nearing the surface of the planet. It looks like a fireball hurtling closer and closer at a truly incredible speed. Soon, it becomes obvious that the collision is inevitable. Bam! The impact leaves a huge crater. It evaporates thousands of cubic miles of solid rock, and it also sets off a series of terrible natural disasters. I know what you're thinking. You believe I'm talking about the catastrophic collision that occurred around 66 million years ago on Earth. You know, the one that's responsible for the extinction of non-avian dinosaurs and 3/4 of other life forms on our planet? But no, the disaster I'm talking about happened on a different planet. Scientists think that our close neighbor, Mars, once experienced the same catastrophe that struck Earth. It happened around 3.4 billion years ago. An asteroid collision might have caused a mega tsunami on the red planet, similar to the one that caused the Chicxulub impact on Earth. Scientists have identified an impact crater on Mars that was probably left by a comet or asteroid collision with the surface of the planet. Most likely, the space body landed in an ocean in the Martian northern lowlands, and the impact was so powerful that it caused a mega tsunami. Before the latest studies, the exact location of the impact crater wasn't verified. It was just a theory. To confirm it, a team of astronomers simulated a comet and asteroid collision in the area where they supposed the impact crater was. They even named this crater Hall. pole is 68 miles across and lies in a region that is almost 400 feet below the supposed sea level. Anyway, the simulations form several craters of the same size as Pole. One of the simulations claimed that these craters had been left by a 5-mile-wide asteroid that had encountered strong ground resistance. The other simulation showed that the craters had been caused by a bit smaller asteroid that met a weaker ground resistance. But, according to both simulations, the impact crater was almost 70 miles in diameter, and the collisions produced mega tsunamis up to 900 miles away from the center of the impact site. The simulations also helped scientists estimate the height of the tsunami. It was about 820 feet tall, almost as tall as the Eiffel Tower. The authors of the study also suggest that the Pole crater might be similar to the Chicxulub impact crater on our planet. The Chicxulub asteroid, as we now know it, is believed to come from the outer reaches of the solar system. This space body was at least 6 miles across. It crashed into the shallow seawaters near the Yucatan Peninsula. This splashdown was so powerful that it left its signature on the entire face of the planet. In 2021, researchers found out that the collision had carved mega ripples into Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists remodeled the events of the first 10 minutes after the impact, and the model showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. That's like 2 Burj Khalifas, which is the tallest construction in the world, stacked one on top of the other. And of course, all that empty space didn't stay empty for long. The ocean gushed back to fill the crater. But in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. Imagine a 3-story building rushing up to you. No wonder the largest and fastest moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall, which is taller than the Statue of Liberty, and moved at a speed 10 times greater than more distant tsunami waves. But back to the red planet. Some experts think that not 1 but 2 mega tsunamis could happen on Mars. They could be triggered by a pair of meteor impacts that were several millions of years apart. Between these 2 collisions, Mars went through a period of climate changes. As a result, liquid water on its surface turned into ice. In other words, the first asteroid impact most likely produced waves composed of liquid water, and the second tsunami was probably formed by rounded chunks of ice water. By the way, the largest asteroid to have ever crashed into Earth might not actually be the one that ended dinosaurs. A much more catastrophic collision likely happened about 3.5 billion years ago. New evidence scientists found in northwestern Australia suggests that the asteroid I'm talking about was 12 to 18 miles across. It struck Earth at an immense speed, releasing an unimaginable amount of energy. Now, this made me think, what if something like that happened these days? More than 30,000 objects that are circling Earth these days could potentially crash into our planet. NASA considers around 1,500 of them to be potentially hazardous. These space rocks are the remains left after the solar system was formed some 4.6 billion years ago. For example, in 2004, astronomers discovered a huge asteroid nearing Earth. The first observation showed that the chance of the space rock hitting our planet was less than 3%. The asteroid was named Apophis. It's more than 1,200 feet across and weighs about 20 million tons. It's supposed to streak across the sky on April 13, 2029. Apophis will pass at a distance of 19,000 miles away from Earth's surface. But even though this space rock might miss our planet in 2029, it doesn't mean it won't return 15 years later in 2036. If such an object hits our planet, The consequences will be unpredictable. They can vary from shattered glass and broken windows to most life forms getting wiped off the face of the Earth. And it'll probably affect the internet. Now that last thought is truly scary. But luckily, modern technologies are likely to help us avoid any catastrophic consequences. Experts have developed several ways to prevent a real-life disaster movie from happening. For one thing, we could use a spacecraft to knock this visitor from outer space off its course, or it could somehow be blasted into pieces. Scientists could also slow the thing down with the help of concentrated sunlight, or people could tug it away with a gravity tractor. That's a theoretical spacecraft that can influence objects in space without touching them. In sci-fi movies, a huge asteroid often sneaks up on Earth and turns out to be a nasty surprise to astronomers. It hurtles toward our planet at breakneck speed and gets discovered just weeks or even days before the collision. In reality, scientists are constantly watching all large objects in Earth's neighborhood. It means there would be plenty of time to do something before the inevitable happened. There are 3 kinds of missions scientists could prepare at short notice. Type 0, when a heavy spacecraft hurtles toward the intruder with one single goal, to knock it off its course. In this case, astronomers would have to rely on the already available information. The Type 1 mission would involve a scout. It would be launched first to get more close-up information about the space rock. Only after that, the main spacecraft would be launched. With more precise information, its journey would be way more productive. And if scientists chose the Type 2 mission, they would send a scout and a small spacecraft at the same time. The spacecraft would knock the asteroid a bit off its course. Then the scout would collect all the necessary information. Based on this data, the spacecraft would finish its job with a more fine-tuned second push. If none of these methods work, people could try going deep underground or even build a shelter on the ocean floor. But in this case, we'd need to find sources of energy that could help us survive for at least several decades. Plus, people would have to create a life support system that could somehow keep air and water fresh. What a nice cosmic family. Meet Mars. I bet you've met him before. These 2 little guys are Phobos and Deimos, Mars's small moons. But it seems like Mars isn't treating the little ones the right way. Phobos and Deimos are believed to be captured asteroids. However, Phobos is gradually moving closer to Mars due to gravity, and it is predicted that it will eventually be destroyed by the planet's gravity within the next 35 million years. I won't be around then. So, I imagine this will result in a ring of debris around Mars, similar to Saturn's rings. However, this process is a natural phenomenon and not an act of destruction by Mars. Apparently, Phobos is getting ripped apart by the crazy gravitational forces of the red planet. But wait, there's more! Phobos has these crazy parallel grooves all over its surface. We used to think that they were from an asteroid crash, but now scientists think they're actually from Mars's intense gravity pulling the moon apart. Talk about a rough ride. Scientists have this wild idea that when a little guy like Phobos gets too close to a big guy like Mars, it starts to stretch out towards it. They call it the tidal force. Phobos is predicted to get stretched out so much that it'll actually break apart. Crazy, right? And the debris from the moon will form a tiny ring around Mars, just like Saturn's rings. Now, some people thought that Phobos' tiger stripes were caused by tidal forces before, but that theory got shut down because the moon is just too darn fluffy. But now, these genius researchers ran some computer simulations and found out that maybe there's a hard shell underneath all that fluff that could create grooves on the surface. But don't worry. At the rate Phobos is going, it's going to crash into Mars in about 40 million years. But if tidal forces are already tearing it apart, it might not even last that long. However, we'll still have the chance to learn more about Phobos. NASA just picked 10 rock star researchers from all over the U.S. to join the science working team for JAXA's Martian Moons Exploration, or just MMX mission. As NASA-supported participating scientists, they'll be helping JAXA explore the 2 Martian moons, Phobos and Deimos. And get this, they're even planning to land on Phobos and grab a surface sample. The mission is set to launch in 2024, and we'll get our hands on that sample in 2029. 7 of the lucky researchers will be using the MMX flight instruments to conduct their research. Phobos is a real oddball. It's only 17 miles wide and orbits Mars at a distance of 3,728 miles, to be precise. Now that's way closer than Earth's moon, which takes a whole 27 days to orbit us. But Phobos is in a death spiral toward Mars and is slowly falling towards the planet's surface at a rate of 6 feet every 100 years. But there must be a reason why Mars is acting that nastily, right? What if it's all just because of plain vengeance? Well, okay, picture this. Mars is minding its own business, being all hot and watery like a young Earth. It's got a sweet magnetic field that's protecting it from cosmic radiation and keeping its atmosphere nice and thick. Hey, life is good. But then, at least 20 asteroids, each the size of a small country, come crashing down on Mars like a giant game of cosmic whack-a-mole. One of them even leaves a crater that's almost 2,000 miles wide. Now imagine how Mars must feel with 2 asteroids being its moons after what other asteroids did to the red planet. All these impacts are like a massive punch to Mars's gut, and its already weak magnetic field is knocked out cold. The core gets all overheated and can't circulate properly, which means no more magnetic field to protect the planet. It's like as if you were wearing nothing at the depth of the Mariana Trench. If it were possible, you'd be defenseless and chilly. That's basically what happened to Mars. So now, poor Mars is out there in the cold, unprotected from all those nasty cosmic rays. It's like going outside without sunscreen. Not a good idea. But at least we can learn from Mars's mistakes and make sure Earth doesn't have the same fate. Maybe we should start investing in some asteroid insurance. But trust me, the red planet isn't mean at all. It's actually pretty friendly. While Mars may seem to be pretty tough for Phobos, there's something that might be thriving with Mars's help. So get this, a team of scientists found a way to grow rice on Mars. Yep, you heard me right. They used MMS, not the outdated way to send pictures, but a special soil called Mojave Mars Simulant. It's supposed to mimic Martian soil. And here's the catch, Martian soil has these nasty percolate salts that can be toxic for plants. So the team grew 3 types of rice, 1 normal and 2 gene-edited with mutations that make them better at handling stress like drought or salinity. And guess what? The mutant strains were able to root in soil with 1 gram of percolate per kilometer. Take that, Martian soil. But hold up. The rice grown in the MMS didn't turn out as great as the ones grown in regular potting soil. So the team decided to mix a quarter of the potting soil with the Martian simulant, and looky there, the plants started developing better. Now these scientists aren't just thinking about feeding Martians. They also want to see if their findings can help grow crops in places on Earth with high salinity. And get this, the whole project started when 2 researchers met for coffee and decided to try growing plants together. Well, isn't that nice? I suspect you're about to say, hey, but if you want to grow rice on Mars, you have to ship insane amounts of water from Earth, and it's not easy to quench this plant's thirst. You're right. You need about 449 gallons of water to only grow a pound of rice. But guess what? Scientists made a groundbreaking announcement at the Lunar and Planetary Science Conference in Texas. They found a relic glacier near Mars's equator. That's right, water ice on Mars, even near the equator. This is huge news, and could mean there's even more ice just below the surface. It's not just any glacier, it's a relic glacier that's estimated to be 3.5 miles long and up to 2.5 miles wide. It's like the size of a small town. It's got all the features of a glacier, including crevasse fields and moraine bands. But get this, it's not actually ice. It's a salt deposit that formed on top of the glacier while preserving its shape. So, how did this salt deposit form? Well, it turns out that volcanic materials blanketing the region might have something to do with it. When these materials come into contact with water ice, sulfate salts may form and build up into a hardened, crusty layer. Over time, erosion removed the volcanic materials, exposing the sulfates and revealing the glacier's unique features. This glacier is young, likely from the Amazonian geologic period. That means that Mars has had surface ice in recent times. Who knows what other icy secrets Mars is hiding? But hold your horses, there's still more research to be done. Scientists need to figure out if there's still water ice preserved underneath the salt deposit, or if it has disappeared entirely. And if there is still water ice at shallow depths near the equator, that could have major implications for human exploration. Imagine being able to extract water from the ground at a warmer location. That would be a game changer. So let's see what else these scientists uncover about our favorite red neighbor. Maybe someday we'll even get to visit that salt glacier statue in person. See you next time. Earth. The third rock from the Sun. The blue planet. You get it. Its atmosphere is made up of around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide. A nice balance for any living creatures to breathe. The weather here is also perfect for life to exist, unlike places like Saturn, Mercury, or any other celestial object in our solar system. We have the troposphere to thank for that. It's the densest part of the atmosphere on our planet and is 5 to 9 miles wide. It's the layer of the atmosphere that always affects our weather and secures the right conditions for life to exist and to have bodies of water. Earth is just sitting in its orbital path, minding its own business, revolving around the Sun until, BAM! Venus and Mars swoop in and spoil the fun. No one wants to leave poor Earth alone. These two relatively large celestial objects moving toward Earth will have dire consequences for our planet, starting with changes in its orbiting trajectory path. The planet's orbits in the solar system have to maintain the right balance so that nothing goes haywire. Of course, if any large object approaches Earth, it would throw our orbiting path off course. The planets will revolve around each other, which will cause plenty of natural disasters on our lands. This will also affect our rotation timing, potentially slowing it down. Days will not flow but drag by. Animals that rely on daytime will need to readjust their biological clocks. Nocturnal animals will also need to figure out how to cope with the long nights. Humans have adjusted pretty well to the 24 hours a day timing. Time itself is just a human construct to measure things. We'll have a tough time sleeping and adjusting to the stretched day. Marine animals rely on the natural current flow to migrate around the oceans. With Mars and Venus crashing the party, it looks like they will also need to find new paths. Birds migrating to other lands throughout the year will also be confused and not know what to do. In general, the Earth's temperature will rise, and massive heat waves and permanent climate changes will occur. This brings us to our next issue, the heat. The radical temperature rise will turn everything into a barren desert. It'll be summer all year long, especially if Venus is in the picture. Most of the planet will dry up and won't be suitable for growing crops. Venus is hot, really hot. Even though it's not the closest planet to the Sun, it's still the hottest. The temperatures on Venus are close to 900 degrees Fahrenheit, which will melt you like an ice cube. The lands on Venus are generally flat, probably due to the temperatures. It's mainly hot because its atmosphere is thick and traps the hazardous gases inside. If Venus inches its way towards us, it'll invite those gases to our atmosphere and compromise it. Mars, or the red planet as we know it, is very cold. That might stay the same if it starts rotating around us. It's also home to the largest dormant volcano in our solar system, which makes Mount Everest look like a tiny bush compared to a tree. With so much instability, it might just wake up one day and spew out molten lava. Mars has a very thin atmosphere, which makes the planet chilly. Its gravity is quite similar to ours. It's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and sunset. The three planets orbiting each other will eventually collide. It's just a matter of time. And the Moon, just hanging out like a fly on the wall, will be so insignificant that something will eventually throw it off course and another planet will capture it to its orbit. Or, in the most dire case, it will collide with one of the two intruding planets. Earth will experience extreme tidal waves like nothing before. The two new planets revolving around Earth will cause a major imbalance, making our gravity shift out of control. Each tidal wave will be bigger than the previous one and will cover the dry land. Plenty of little scattered islands in the oceans will be completely submerged. Coastal cities and towns will also be home to fish. Flat countries in general will need boats to get around. Dams and dikes won't be enough to stop the water from coming in. Everyone needs to move towards higher ground to escape the floods. With the climate getting hotter, the polar caps will melt like ice cream on a sweltering summer day and add to the water level rising. Within a few months, the whole Arctic will be nothing but liquid. But wait, there's more! The crust will wear out due to the instability of the Earth's surface and fluctuating gravity. The Earth's crust is mainly made up of oxygen, which means we're basically walking on air. We might experience more earthquakes than before, and dormant volcanoes will wake up from their deep slumber. The skies will be covered in ash, making flights impossible. No one can travel by sea or by air. Importing and exporting will become history. The overall climate will get hotter, just like in Venus. The three planets orbiting each other and their huge mass might even unintentionally welcome other planets and celestial bodies to join the party. So, what if Jupiter decided to turn up? Now, Jupiter is the largest planet in our solar system. To give you an idea, the Earth would be just the size of a grape if Jupiter were the size of a basketball. It also has the largest storm we can perceive. That's known as the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. Now, by the time you're done watching this video, you can expect the storm to still be going at it. Since the planet is huge, gravity must be quite strong here. It also has many moons, some of them of our little Earth. There will be no room for any proper space among the planets. Jupiter's moons will be thrown off course and latch onto other planets around. Some of the moons might collide with each other, causing massive debris to be displaced all over the place. The gravity of the planetary party will attract comets to enter the atmosphere, potentially crashing down on us. Oxygen levels will deplete, so the Earth's crust crumbling will continue. It'll rip open the ozone layer, causing heavy strokes of ultraviolet waves to enter our atmosphere. We won't be able to step outside for too long without some protective gear and oxygen tanks. Human civilization will change drastically. We'll all live in sheltered containers that will provide clean air and safe and filtered sun rays. The shelters will be sturdy enough to withstand frequent earthquakes. We will grow only enough crops to sustain ourselves until we leave the Earth. Since it'll only be a matter of time before the planets collide, the next step would be to create large rocket ships to fly us out of the Earth. With Mars, Venus, and Jupiter revolving close to us, it won't be easy to do so. All the space debris will be blocking us from exiting the space zone area. The only safe place outside this region will be many millions of miles away, where only single planets exist. They may or may not have the conditions to host life, but humans will have the technology to land just about anywhere with similar gravity and construct the right shelters. Eventually, Mars, Venus, Earth, and Jupiter will collide with each other and break like eggs, like a big space omelet. Don't forget the moon's crashing and breaking in the mix, but we'll already be far, far away by then, hopefully. Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far, though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around. so these events happen more often than you'd think. For a solar storm to begin, our Sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These two phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under 2 continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the moon is so dry and doesn't have much of an iron core. But why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington event, which happened way back in September 1859. It gave us a sneak peek of what the power of the sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed two enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong, their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges. Bang! Another hit on Jupiter. Let's see. Gas giant, the largest planet in the solar system, 318 times bigger than the Earth, 2.5 times bigger than the rest of the planets in the solar system put together. One more interesting thing. If it got any bigger, it would actually become smaller. You see, with more mass, the planet would be denser. That would cause Jupiter to start pulling in on itself. Scientists say Jupiter could have 4 times greater mass but still keep the same size. It takes 10 hours to make a full rotation on its axis. It's the fastest spinning planet in our solar system and gets hit by so many space objects all the time. This was discovered by amateur astronomers observing Jupiter and saw some unusual flash at the planet's surface. Impact events cause flashes like that, and for some reason, Jupiter gets more impacts than other planets. In 1994, astronomers discovered Shoemaker-Levy 9, a comet that broke apart and collided with the gas giant. The original comet was approximately the size of one that erased the dinosaurs. However, this asteroid fell apart into more than 20 fragments. They darkened the planet's surface, and it remained like that for months. 15 years later, in 2009, astronomers saw a black spot on Jupiter, the size of Earth. It was the result of an asteroid around 650 to 1,650 feet in length. The biggest asteroid recorded on Earth hit the area of Tunguska, Russia in 1908. This caused a massive explosion, even though no one ever found a crater. So, why is Jupiter the target for so many space objects? Asteroids and comets that pass by Earth and Jupiter go almost at the same speed. The number density of the space object that may interact is almost the same too. But the cross-section of what they might hit is very different. Jupiter has 11 times the diameter of our planet, which means it has around 125 times the cross-section. The more massive some planet is, the stronger its gravitational attraction. So, it will entice some space objects drifting by. Our gravitational field is weaker than Jupiter's. If some object passes near us moving at a speed of 22,300 miles per hour or less, our gravitation will attract it. Asteroids and comets usually move at bigger speeds. Jupiter attracts most of the comets and asteroids passing by. If our planet was hit by such big objects as frequently as Jupiter, we'd have extinction like with dinosaurs thousands of times more often. In 2020, scientists found there was an unusual asteroid in the orbit of Venus, the first one there. The size of a small mountain and rich in minerals we can find in Earth's deep rocks. They even think it could be a clue to a bigger set of asteroids created when our solar system was forming. That's not the only mystery around Venus. The planet has insanely violent winds that drive clouds and storms around the planet at speeds greater than 220 miles per hour. That's 60 times faster than Venus itself rotates. Also, scientists are still not sure what happened with its oceans. They believe since the planet is so close to the sun, the water evaporated and went into the atmosphere as steam. It trapped heat coming from the sun, heat that would have vaporized more and more water over time. Venus probably had an environment like on Earth, but a very long time ago. The theory says many comets and asteroids were slamming into Venus. Billions of the planet's pieces were flying all around. Some may have even crashed into Earth's moon. Pieces that slammed into our planet are probably buried very deep, since we have greater geological activity than the moon. Uranus also had a collision, but a more serious one than asteroids. The rest of the planets in our solar system mostly have an axis of rotation that kind of points up from the elliptical plane. Uranus is tilted, lying on the side, so a season there lasts 42 years, when either its south or the north pole is pointed at the sun. Most of the planets also rotate counterclockwise when you see them from above our solar system. Venus does the opposite, which means maybe it was kicked off axis a long time ago. Uranus may have collided with the other space body millions of years ago. When our solar system was still very young, the orbital configuration of Saturn and Jupiter may have crossed. Their gravitational forces kind of created orbital momentum and transferred it to Uranus. That knocked it off axis. Millions of asteroids orbit the Sun, and not so many pass by Earth from time to time, so we don't have some dangerous space bodies coming toward us. The plan is to visit Mars in the 2030s, and scientists hope Mars won't be a target of some bigger space bodies. New craters are formed on the red planet every 1 to 2 days. They can be 13 feet across, which means they could have been formed by objects that are the size of a soccer ball. Since the atmosphere there is thinner than ours, smaller bodies can enter easier. Most of the Martian north is smooth lowlands. The south is higher, full of craters, and the planet's interior has a surprising amount of rare metals. The theory says this is because a big celestial body collided with Mars and tore away a part of its northern half. Debris from that asteroid circled the planet and then mixed into 2 small moons that orbit Mars. We also have some Mars rocks on Earth, found in the Sahara Desert, Antarctica, and some other places across the globe. Some of these rocks have gas that's chemically the same as the atmosphere on Mars. Rocks probably came due to a big explosion that happened when some larger asteroid or meteor that was ejected from Mars and landed on our planet. Mercury also has a thin atmosphere, so there are many smaller strikes there. Imagine waking up, going to your window, and see there are micrometeor showers every morning, which is something that happens on Mercury. This strange weather pattern shapes its atmosphere, called an exosphere. Mercury is so dense, its heavy iron core accounts for 2/3 of its total mass. Scientists think it could have been bigger in the past, but many collisions got the surface sort of scraped off. It's been constantly bombarded by rocks from space that left marks with craters. Plains on its surface seem to have been created because of volcanic lava spilling over the surface and then dried smooth. Many craters are filled with such a material, which means there's one more thing that rocked Mercury's world: volcanoes. There's an unusual group of asteroids discovered near Neptune. Wide range in sizes, from big metropolitan areas to tiny pebbles. They are thought to come from an asteroid group called the Kuiper Belt. It makes a ring well beyond Neptune. But these new asteroids have different colors than the Kuiper Belt. They're so far away from the Sun, their surface was supposed to stay almost pristine, but they have a similar color to those sun-baked asteroids around Jupiter. Like the rest of the planets, Neptune gets heat from the Sun. But there's something mysterious inside the planet that makes it generate more heat than it gets. This affects its weather, and Neptune has the weirdest weather in the whole solar system. Massive storms, insanely high winds, cirrus-like clouds that rapidly change all the time. There are dark spots in its atmosphere. They come and go. We receive 1,000 times more sunlight than Neptune. Gas giants like Saturn and Jupiter can protect our planet from asteroids. Without them, the big impacts that created enough debris to form both moons and other planets would happen more often. There's a huge asteroid going around Saturn, which could be a potential flyby by 2031, more than 10 times bigger than the asteroid that erased the dinosaurs. Titan, one of the moons orbiting Saturn, 80% more massive than our moon, is actually the only moon in our solar system that has an atmosphere. It's 1.5 times thicker than ours and consists mainly of nitrogen, like our atmosphere. No one knows where all that nitrogen came from. However, unlike Saturn and most of the other places in our solar system, its moon has a real potential to host life.
Something's moving toward our planet that could end all life on Earth. It's a regular needle, weighing about 5 grams. You're probably wondering why it's so dangerous. Can something that small really do any harm? It's hard to say, because it's moving at the speed of light, and we don't really know what will happen when it hits. That's because the idea itself is hypothetical, so it leaves us with a bunch of questions. Here's the first one. What happens to a sewing needle in space? Could it actually accelerate to the speed of light? The short answer is no, but it's not that simple. In our universe, nothing that has mass can reach the speed of light. It takes energy to make any object go faster. Since there can't be an infinite amount of energy, nothing can ever accelerate that much. So in our case, we can simplify things. Let's say that the needle is moving at 99.9% of the speed of light. That's about 186,000 miles per second, or 670 million miles per hour. At this speed, the journey from the Earth to the Sun would take about 8 minutes. For comparison, the maximum speed of a Falcon Heavy rocket is 24,600 miles per hour. And the fastest car on Earth is more than 2 million times slower than the speed of light. The biggest rock to ever hit our planet was the Phobos meteorite. It weighed about 60 tons. It fell to Earth around 80,000 years ago and caused a lot of damage. Would something as small as our sewing needle be able to have the same effect? Sure it would. It's all about the energy involved. Small things traveling at almost the speed of light would have more energy in them than really big but slow-moving objects. So our speedy needle would hit the ground much harder. On impact, all the energy it contained would cause a mighty big kaboom. Everything nearby would just disintegrate. But could such a big explosion really destroy our entire planet? Let's compare this to the biggest blast humans ever made. The cloud of debris that followed this explosion was 40 miles high. It could be seen from a distance of 100 miles. About 50 megatons of explosive force was released into the atmosphere. The energy our needle would release as an explosion would be about 43 kilotons of force. That's less than what humans can cause, but it could still lead to massive damage. So if you hear on the news that something is headed for Earth at the speed of light, you'll definitely need to find some cover. Could people survive a collision like this? Well, it would be pretty scary. A dazzling flash of light would be followed by a shock wave of incredible force. The glass in all houses within a 2.5-mile radius would be smashed. Even the strongest buildings would collapse. All that energy coming from our needle would cause seriously big fires up to 1.5 miles from the epicenter. Everything at this spot would essentially be vaporized. The situation would be a little different if the needle went into the ocean. Just like a meteorite, its impact would cause a huge tsunami, but the shockwave wouldn't affect big cities, and people probably wouldn't be hurt. Although if it hit off the east coast of the United States, this tiny object could still cause flooding in New York. But other things could happen if a needle like this entered the Earth's atmosphere. Because it's moving close to the speed of light, the needle won't actually be a solid object anymore, but more like a bunch of atoms flying alongside each other. So it's possible that the needle would just pass right through our planet, the same way it would cut through a balloon. It would happen very quickly, in a split second. No one would even notice, and people would just go about their business. But here's the most incredible possibility. What if the needle hit a person? Well, there's a very small chance of that happening, just 1 in 1.6 million. Although something similar happened at least once, when 2 men in Turkey experienced rain made of rocks in 1888. But let's get back to our needle going at light speed. If the human body completely absorbed all that energy upon impact, it would just disintegrate. But there's another possibility as well. The needle could weaken the bonds between molecules and atoms in your body and pass right through them without causing any pain. You'd just feel something like a mosquito bite. Of course, it would still leave its mark. The needle would make a perfect hole in your body. But so long as it didn't go through your vital organs, you'd be fine. Plus, you could boast about your incredible good luck. The chance of a space needle hitting you is almost like winning the lottery. So it seems a needle moving at light speed wouldn't do that much harm. It might create a big crater in one spot, but the world would be all right overall. But what if something much bigger than a needle flew towards Earth? In 2013, a large meteorite entered the atmosphere above Russia. Luckily, most of it burned up before it reached the ground, but the largest piece of it that survived weighed slightly over half a ton. The meteorite exploded about 14.5 miles above the surface and lightly damaged more than 7,000 buildings. About 1,500 people were injured, but it was only moving at about 37,000 miles per hour. What would happen if it had accelerated to close to the speed of light? An object this big, moving at a speed of nearly 186,000 miles per second, would have an enormous amount of energy. Its impact would basically wipe out an entire continent. The blast wave would have such force that it would completely circle the planet and pull down absolutely everything in its path. The tsunami caused by the explosion would wash our civilization into the ocean. Humans would only survive if they made it to very deep underground bunkers. But once the dust settled and we went back up to the surface, we would find that there was nothing alive left on Earth. It would be more or less the same as when a meteor destroyed the dinosaurs millions of years ago. It's true that that meteorite didn't move as fast, but it was just as big. Of course, our planet recovered from that impact, and life returned. There is actually an object moving around in our solar system right now that could destroy half the Earth. Halley's Comet. It weighs about 220 billion tons. That's a whole lot of zeros. By the way, this comet has come close enough for us to spot it at least 30 times. The last time it could be seen was in 1986, but we'll have a chance to see it again in the not-too-distant future. Its next appearance is predicted for July 2061. If an object like Halley's Comet hit the Earth at the speed of light, it would completely change the shape of our planet. The blast would form a crater the size of Eurasia. After a blow like that, the Earth would never be the same again. Now let's talk about something that's a little more real. although it's seriously weird. Is there anything out there in the universe that can move at the speed of light? Well, almost. Scientists have discovered that some superactive galaxies can spit out hot blobs of gas the size of Jupiter. These galaxies are called blazars. When they studied the blobs, the scientists scratched their heads in confusion because the speed of these things is about 99.9% the speed of light. To accelerate something as big as a bowling ball to that speed would take all the energy produced on Earth for an entire week. So imagine how much you'd need to fire off a Jupiter-sized lump into space. The chances are that these blobs are getting all that energy from supermassive black holes inside the blazars. The hole itself absorbs tons of particles, but also accelerates others and pushes them out into space.
So one day, Edwin Hubble discovered that the universe was expanding, so they named a telescope after him. Well, yeah, there's more to the story. Now, imagine a fruitcake baking in the oven. As this cake is rising, the raisins inside are moving farther apart. Something similar happens when the universe expands. But instead of raisins, there are galaxies, which start to spread out. That's why if you randomly pick any two galaxies, the chances are they're moving away from each other. But then the question is, if galaxies are moving apart, why are there still galactic collisions? You see, even while expanding, the universe still remains a playground for galaxies to interact with one another, and they mostly do it by using gravity. All galaxies out there attract other galaxies, and their mutual pull slows down the speed of them moving apart. And naturally, the closer two galaxies are to each other, the stronger their mutual gravitational pull is. On a large scale, it doesn't seem to make any difference, since every galaxy experiences a similar pull in every direction. But locally, gravity kinda overwhelms this powerful cosmic expansion and pulls together two or more galaxies which were initially moving apart. That's how galaxy collisions occur. Plus, some galaxy groups, like the Virgo cluster, aren't expanding at the moment, since local gravity has stopped the expansion process in that region. Some large galaxies can attract smaller ones, and then the gravity of the larger galaxy starts pulling a smaller one toward it. Eventually, it leads to a collision. Galaxies are made up of stars, rock, dust, gas, and other materials. When two galaxies collide, their gases begin to interact. These gases usually exist in large clouds spread throughout galaxy systems. Because of their size, large clouds of gases are more likely to run into large clouds of gases. Then they start getting denser and experience more pressure. Or the combination of gases can cause waves, and the gases can collapse on themselves. Both of these processes lead to the formation of new stars. If two colliding galaxies are of the same size, many new stars are likely to form, making the galaxies shine even brighter. But if the speed of these two galaxies is too high, the newly formed stars can go right out after they appear in the sky. As two galaxies start coming closer to each other, they begin to stretch and deform, creating arms or tails. As a result, an elliptical galaxy can form, or the collision can form a new supergalaxy. In this case, stars from each galaxy will have to find a new place within this gigantic space formation. But of course, there are tons of galaxies that have never collided with others. That's because galaxies are actually relatively small targets in our gigantic universe. They form groups of small clusters where dozens, hundreds, or even thousands of galaxies gather together. Gravity holds them tight together, just like the solar system stays together thanks to the sun's gravity. Galaxies roam within these groups and clusters in a disorganized way. Naturally, collisions are bound to occur, but since galaxies are tiny compared to all that space they live in, massive mergers don't happen often. I'm talking about those collisions between equal-sized galaxies that shake things up on a grand scale. Of all the environments galaxies can live in, the most dangerous place is a group. Because solitary galaxies, living out in the field, seldom cross paths with others. As for galaxy clusters, they are indeed crowded. But galaxies in them move at such breakneck speeds that even if two of them meet, they'll simply race past each other without any dramatic consequences. But groups of galaxies are a different story. There, galaxies move comparatively unhurriedly. It makes it more likely that two galaxies in a group will not only come close to each other, but also get caught in their mutual gravitational pull for a prolonged time. And what will happen if two galaxies come close enough to collide? Well, the best way you can imagine such events is by thinking of them as merges rather than collisions. Galaxies are very spacious, and it's more likely that the stars they contain will just pass by each other. Let's talk about a galactic collision that, according to astronomers, is going to happen in several billion years or so. And our home Milky Way galaxy is going to take part in this space event. But don't worry, we still have some time to brace for the impact. Interestingly, there might be not one, but two collisions. And the first one might happen around, 2 billion years from now, when the Milky Way will collide with the Large Magellanic Cloud. This spiral of stars and dust is floating in space about 160,000 light-years away from our galaxy. And although right now this distance is totally safe and you have nothing to worry about, in approximately 2 billion years, the two celestial bodies are likely to collide. And what a view it's going to be! Imagine the Milky Way nearing the smaller galaxy. The supermassive black hole residing in the center of our galaxy will wake up and start gobbling up the stars and gas clouds of the Large Magellanic Cloud with enthusiasm. Thanks to this new food source, the hole will grow way bigger than it is now. It might even turn into a quasar, one of the brightest things you can find in the universe. Our newly awakened black hole will also be emitting long jets of super bright radiation. But people on Earth won't have anything to worry about. These jets won't reach our solar system, and even if powerful gravitational interactions triggered by the merger could probably fling us out into intergalactic space, the chances of this happening are slim. Like me winning the lottery. Stars are located too far away from one another, and even such a catastrophic galactic smash-up isn't likely to jostle our solar system. Now, if our black hole does turn into a quasar, it'll be an even more breathtaking view. The thing about these celestial bodies is that their light can be up to 10,000 times brighter than the light coming from the whole Milky Way galaxy. That's why Earth's night sky might change beyond recognition. The newly born quasar will get rid of some stars and send others flying billions of miles away from their orbits. As a result, all the constellations, as we know them, will disappear from the sky after the familiar stars get too far away for us to see them with the unaided eye. Luckily, the chances that the Sun will get knocked out of the Milky Way are really infinitesimal. But how about the predicted collision with the Andromeda Galaxy? Will our solar system survive this catastrophe as well? Right now, the Andromeda Galaxy is nearing the Milky Way at a speed of 68 miles per second. As you may guess, it's very hard to figure out its actual speed. And until 2012, researchers weren't even sure if the collision was going to happen or not. Unfortunately, it turned out that we had to prepare for the appearance of Milkdromeda, or Milkomeda, a structurally new galaxy consisting of the merged Andromeda and the Milky Way. Now, on the other hand, such collisions aren't something out of the ordinary if you consider galaxies' lifespans. Besides, even though the Milky Way is home to more than 100 billion stars, and the Andromeda Galaxy contains about 1 trillion, the chances of several stars colliding during the galaxy's merge is really low. The reason is the same: stars are located too far away from one another. For instance, the closest to our Sun star, Proxima Centauri, is more than 4.2 light-years away, which is about 30 million diameters of our Sun. In simpler terms, if the Sun was the size of a ping-pong ball, Proxima Centauri would be the size of a pea located 680 miles away, and the entire Milky Way would be 19 million miles wide. Wow! As for other stars, can you imagine ping-pong balls hanging in space every 2 miles? Great! Now you have a miniature model of our galaxy.